Good morning, class. So today for our learning target, I can write a linear inequality and determine if points are solutions by checking the solution set and or if the point makes a true statement. So this is similar to what we did last week. We're still going to graph, but we're going to write one as well from a word problem. And for today, thinking more than none will be required. So make sure you are thinking as you are working. For our agenda today, I want you to look at completing the writing inequalities videos notes. So what you're watching right now, you're also going to complete the writing inequalities classwork, number 1, number 2, and number 4. I'm going to do number 3 with you today. And then if you get any time early in class, you can finish the work from Thursday or Friday because that work was also due on Friday. I want you to find problem number 3. So flip your paper over and make sure you're working on problem number 3. And this is just the first part of problem number 3. There's actually more than just these 3 parts we're going to go over together. So let's go ahead and read the scenario. It says, suppose you have 2 summer jobs and want to earn no less than $300. You earn $15 an hour grooming animals and $60 an hour tutoring part-time. And so with this scenario, we want to define variables, write an inequality to find the number of hours you can work each job, and we also want to graph the solution set. So the first thing we want to do is to define our variables x and y. We've actually done this before, so this part is not necessarily new, but x represents something in the situation and so does y. For our purposes today, I want us to actually define our variables based on the graph. So the graph down here is going to let you know what x represents and also what y represents. So in this case, go ahead and label the x-axis x, which is the horizontal axis, and the y-axis y. And by doing that, I already know that, hey, the x variable represents the number of hours we're grooming, and the y variable represents the hours that we are tutoring. So we can go ahead and put that down on our paper. So now that we have our variables defined, so hopefully you have written that down as well. X is the number of hours grooming animals and Y is the number of hours tutoring. For part B, it says to write an inequality to find the number of hours you can work each job. So our inequality is going to be in standard form where we have something times X plus something times Y. And then here we have an inequality symbol and then C, the total. So to determine which inequality symbol we can use, we're going to look at the highlighted word in the problem, which is no less than. So if I'm working these 2 jobs, so I'm grooming animals and I'm tutoring, and I want to earn no less than $300, which one of these symbols would best represent no less than? Can we earn less than $300? Can we earn more than $300? Do I want $300 or less, or do I want $300 or more? So the word no less than means that I want to earn $300 or more. So when I write my inequality, it's going to be this symbol here, because this represents that I can earn $300 or more, the greater than or equal to symbol. And now we just have to figure out what our rate for x is and our rate for y is. Since x here we wrote represents the number of hours grooming animals. Well, how much money am I being paid per hour to groom animals? Well, $15. And since y represents the number of hours tutoring, I'm getting paid $60 per hour to tutor. So when I write my inequality, I'm going to use those 2 numbers, 15 and 60, in place of A and B. And so here in my problem, I have went ahead and circled the 15, and then next to hours grooming animals, I wrote my X, and then I've circled the 60, and above the hour working part-time, I written my Y. So now we can write our inequality, and our inequality is going to be 15x plus 60y is greater than or equal to 300, because that's how much money that we would like to make or more in those two jobs. So part C, we want to graph the solution set. And we've already graphed this in our calculator. We just need to transfer it to this grid here, or this coordinate plane. So we want to take this and we want to type this into our calculator so that we can find the y-intercept, the x-intercept, and then we can graph it. All right, so to graph the inequality, go to your calculator, pull up the graph, and we want to delete the equal sign so we can get our relation. And we want to go ahead and type in that equation. So 15x plus 60y. And to get if it's greater than or not, we hit Control equal, and we select greater than or equal to 300, and we hit enter. Now here we can only see part of the graph. We want to be able to see everything. So when we start to trace the line, it will move. So now you want to go ahead and get your x and y intercepts so that we can graph it. And to get the x and y intercepts, we can do the same thing we've always done, and that is menu, trace, and graph trace. And so this is my y-intercept, and you want to move along the line until you get to the x-intercept. So now that you have determined that the y-intercept is 5 and the x-intercept, or the 0, is 20, we need to connect these 2 points, making our line, and then we want to shade in the solution set for the inequality. So we first have to determine, is the line solid or is the line dashed? And you can do that by looking at the calculator. It will tell you if it's solid or dashed. So if you go back to the calculator, if you want to determine if it's solid or dashed, first hit the escape button to get out of trace. And then if you take your finger and you just gently hover over the control pad and you get to the line here, it's a solid line. It has no breaks. So when we go back to our problem, we are going to connect those 2 points with a solid line. So make sure that you take your ID badge or something you can make a straight line, and we connect it. And then also for the shading, I want to determine how it's going to be shaded. So I'll go back to my calculator, and if I look at my graph here, I can see that the shading is above the line. So if you're still not quite sure how to determine if it's above the line or below the line, think about if you were walking on this line. So here you are. Which person is standing on top of the line? Well, this person is over here. This person is on top of the line. This person is standing on the bottom of the line, and the top part of this line is shaded in. I also said in one video to look at the y-intercept, and my y-intercept is 5. And here 6, 7, 8, and 9 are greater than 5. Those are colored in, so that also means above the line. The numbers less than 5 are not shaded in, and so this would be the bottom of the line. So there's several different ways you can determine which side is above the line versus below the line. So here we have now done our shading, which is above the line, and this shaded area is called the solution set. So make sure you have your shading nice and neat. And we are going to use this graph of the inequality and also this equation to answer the questions for the other parts that are below A, B, and C. So for parts D through H, we want to use the graph of our inequality to answer each of these parts. For part D, it says which ordered pair are possible combinations for the number of hours you would work each job. Remember, we want to earn no less than $300, so that's what this shaded region represents. This line that we graphed would be earning exactly $300, and then this blue shaded region would be if I wanted to make more than $300, because that's the top of the line. The bottom part would be if we made less than $300. So we want to determine which of these points would be possible combinations of me earning no less than $300. And for this to be a possible combination, so if we're going to have a possible combination here, then we know that one of these points, they would have to be in the blue area here. So if we look at this point, 4, 3, and I find the location of that point on the graph. So here's 4, here's 3. Since this particular point is not in the blue area, then this is not a common solution. So you'll have to graph each of those points to determine if they are solutions or not. This one is not. For the second one, E, it says, what does the point 18.4 represent in the context of the solution? So we need to find 18.4. Here's 18, and if I go up 4 units, so we could put a point here on the graph. And so I'll do that in a different color, 18.4. So that is a solution. And since 18 is my X value and 4 is my Y value, that tells me that I can earn 18, or I can work 18 hours grooming animals, so that's my X, and 4 hours tutoring to earn no less than $300. So let's go ahead and put the $sign there, since we're talking about money. For F and for G, we're looking at what does the y-intercept represent in the context of the situation. So here's my y-intercept. And what does the 0 represent in the context of my situation? So here is my 0. So we want to kind of figure out what those meaning are. And it's going to be the same meaning as this. We just have to figure out what the ordered pair is for the y-intercept and the 0. So here we can see that the y-intercept, which was 0.5, represents that I can only work, or I can work only 5 hours tutoring to earn no less than $300. Since the ordered pair is 0.5, 0 means no hours grooming animals, and then 5 means only 5 hours tutoring to earn your $300. And then what does the 0 represent? Well, its ordered pair is 20. So I can work only 20 hours grooming animals to earn no less than $300. So this point would be you only working tutoring, or you only grooming animals and not tutoring. And then lastly, what is a reasonable domain and range for the situation if you made exactly $300? So normally we can't find domain and range from an inequality, but we can find domain and range from the boundary line, which is this red line that I've added to the graph. So since we've done domain and range before, we can go ahead and find it now. We know that this is continuous because X values, and the graph for the X value is between 0 and 20 because the graph starts at 0. So if we look over here, this is 0 for the X values and it goes all the way to 20. And then our range, which is the Y values, it's going to be from 0 to 5. So that represents my domain range. So now you should be able to complete the remaining problems on this assignment in the time that we have allotted in class. If you have any questions, feel free to ask. I'm in the classroom.